Hello, good morning students. Welcome to TOES classes once again. Today we are going to discuss a very important topic of class 12 physics, and that is the superposition principle or the principle of superposition for electric charges. Let us see how we can apply or write this principle. Okay. So for this I have considered what I consider. I consider a point charge plus q1. Let this point charge plus q1 is surrounded by another charges. Suppose this is charge q2, this is charge plus q3, and suppose this is charge plus qn. What I have considered? I consider or let a point charge q1 plus q1 is surrounded by n point charges. How many point charges? N point charges, and these are q2, q3 and up to qn. And let these all charges are placed in vacuum or air. Okay, what will happen? The charge q2 will apply a force of repulsion on q1, because we know that like charges repel each other. In the same manner, q3 will apply a force on q1, because we are going to calculate the force, electric force, which is acting on charge plus q1. Okay, so I have considered the distance between q2 and q1. This is, I consider this is r12. In the same manner, I consider the distance between q3 and q1, that is r13. In the same manner, the distance between you can write down the distance between q1 and charge qn, that is equal to r1n. So I have considered r13, that is the distance between the charge q2 and q1, r13 distance between the charge q1 and q3, and r1n, that is the distance between charge plus q1 and plus qn. Okay, what will happen? I have to consider what is the force acting on charge q1. So in the beginning I have considered q2 and q1. I am not considering q3 and q4. Okay, so what will be the direction of force? In which direction the force will be applied? The direction of force on q1 will be F12. Actually, what is this F12? That is the force on charge q1 due to charge q2. Force is of repulsion. It is directed along like this one direction, you can show. In the same manner, I can draw the force which is acting on charge q1 due to charge q3, that is F13. In the same manner, I can also draw the force which is acting on charge q1 due to charge qn, that force is F1n. Okay, so what I have write down, I can mention it here like this one. I have to write down mathematically. Suppose F12, I have to write down F12, force on charge q1 due to charge q2, you can write down, that is equal to 1 upon 4 pi epsilon naught q1 q2. The distance is r12 square, but F12, that is a vector, because the sign of vector is here, so I have to introduce one unit vector here. I introduce one unit vector, that this unit vector is r21. That is the unit vector which is leading from charge q2 to q1. It is along the force F12. I have also explained this is vector form of Coulomb law. So I can write here, that is equal to R21 cap you have to introduce here. So F12 is equal to 1 upon 4 pi epsilon 0 Q1 Q2 upon R12 square R21 cap. R21 cap is the unit vector leading from charge plus Q2 to charge plus Q1. Similarly, I can write down the force on charge Q1 due to charge Q3, that will be equal to 1 upon 4 pi epsilon naught Q1 Q3, the distance R13 square, here R31 cap. Like this one, I can write down F similarly F1n, that is equal to 1 upon 4 pi epsilon naught Q1 Qn R1n square and unit vector Rn1 cap. So these are the different forces which are acting on charge Q1 due to the other point charges. Now I have to write down the resultant force. Let's see how I can write down the resultant force on. Therefore, resultant force on charge Q1. Suppose this is F and this F, that should be equal to F12 plus F13 plus dot dot up to plus, and this is the principle of superposition or the superposition principle for electric charges. What it states? It states that electric force acting on a point charge which is surrounded by other point charges is equal to the vector sum of the forces which are exerted by each charge on that particular charge. So what I have calculated here, resultant force is equal to the vector sum of all the forces which has been exerted by the surrounding charge on the charge which we have going to calculate the resultant force. Now I have to put the value of F12 and F13. Let us see what resultant force I am going to get. We place the value F12. First of all, that is 1 upon 4 pi epsilon naught Q1 Q2 R12 square R21 cap plus 1 upon 4 pi epsilon naught Q1 Q3 R13 square R31 cap plus F1n, that is equal to 1 upon 4 pi epsilon naught Q1 Qn R1n square and the unit vector Rn1 cap. So like this way I can write down the values. Now in next step I can take common 1 upon 4 pi epsilon naught Q1 you can take outside. Inside you will get Q2 R12 square R21 cap plus Q3 R13 square R31 cap plus Qn R1n square Rn1 cap, bracket closed. This is the mathematical form of the superposition principle of superposition for electric charges. In terms of summation, I can write down it as like this one. F is equal to 1 upon 4 pi epsilon naught Q1 is outside. This is the sign of summation. I is equal to 2 to n. You can write down Qi R 1I square R I1 cap. So this is the method to write down in terms of summation. What is the meaning of summation? Let's see. If I place a value of 2, I will get the first term. If I place the value of I3, I will get the second term. In the same manner, if I place I is equal to the n, I will get the nth term. So this is the mathematical form. Which form? This is the mathematical form of principle of superposition for electric charges. So what the principle of superposition of electric charges states that, it states that if a point charge is surrounded by another charges, then the electric force acting on it is equal to the sum of the electric forces which has been applied by it. Actually it is the vector sum of the electric forces which has been applied by the separate charges on that charges on which we are going to calculate the electric force. Very important, and in many numericals this principle has to be applied. In my next video I will solve some problems which are related with the principle of superposition. Thank you and have a nice day, and please do comments in comment box regarding this video so that I can I can sort out your problem in my next video. Have a nice day. Thank you very much. Thank you.